In addition to the simple and compound statements we've already seen, we can make what are called quantified statements. And a quantified statement is just a statement that's telling us about a general rule. Now, we're going to be interested in these statements because in deductive logic, we typically have a general rule of some kind or other, either provided as a quantified statement or provided as a compound statement where things are a little bit wishy-washy. Some examples of quantified statements include all frogs are green, some dogs have floppy ears, and no bears are funny. Like other kinds of statements, quantified statements can be either true or false. I mean, all frogs are green. We know that that's actually false. Frogs come in all sorts of exciting colors. Some dogs have floppy ears. That's true. They're adorable. And no bears are funny. Well, funny is kind of subjective, but assuming that that's defined somewhere, that's probably false. Now, when we start to work with quantified statements, we're actually dipping our toes into something called predicate logic, which is very much outside the scope of our course to work with in general. But we're going to just dip in our toes because we really do want to be able to work with some, though not all, of these quantified statements. Quantified statements tell us about all or some of the individuals, people, places, or things in a group. We might say group, we might say category. If we're feeling mathy, we might say set. I'm going to say category for the most part because it seems like the most general one of those terms to me, but it's just like a bunch of things. And we're also going to be really wishy-washy about whether we're talking about people or animals or things or what makes up our universe. If we were going to do a full course on predicate logic, we would get very serious about exactly what makes up our universe. But for our purposes, we can stay a little wishy-washy about that. Now, there are two kinds of quantified statements. A universal statement tells us about all of the items in a category. An existential statement tells us about some of the items in a category. And the biggest thing that you need to know about quantified statements is some does not mean not all. When I say some dogs have floppy ears, I mean I can go out into the world and I can find a dog with floppy ears and hold it up in front of you. I am not claiming that there are dogs whose ears are not floppy when I say that. That is the trickiest part about existential statements. We're not going to worry about it too much. In fact, in this course, we're not going to worry too much about existential statements. But be aware that some does not mean not all. To help us understand these quantified statements and to help us work with them, we're going to use a tool called an Euler diagram. When we draw a diagram like this, our categories are going to be represented by circles, not necessarily perfect circles. They're going to be vaguely circle-ish shapes. You don't have to be a perfect artist. Our categories are represented by circles labeled by capital letters. And our individuals are represented by dots labeled by lowercase letters. Now, as we draw these, if you're familiar with Venn diagrams, you might be thinking, isn't that a Venn diagram? And the answer to that question is no, but the differences between the two are very technical, and we won't really be going into that. If you have never heard of Venn diagrams, that's fine. We're not going to be talking about them in this unit. In an Euler diagram, which is what we're going to be drawing, the categories are represented by circles, labeled with capital letters. Individuals are dots labeled with lowercase letters. Here we have a statement, Linda is a bank teller. Now that's a simple statement, but it is a statement about an individual belonging to a category. We have the category of bank tellers, which we could call Big B, and we have an individual named Linda. Now, I could label that with a lowercase l. I don't like using lowercase l because it looks like a 1. So I'm going to use the letter X to label Linda. So the category of bank tellers is represented by this shape, which I assure you is as close to a circle as I'm likely to draw. And Linda being a bank teller means I draw her dot inside the circle. So being inside the circle means being included in the category. And that's really all there is to it. In the next several videos, we're going to be using these Euler diagrams to help us understand what these quantified statements mean. So our goal in drawing these is to understand the relationships between the categories, not necessarily to get really good at drawing the diagrams.